Nice.
Distillation. What we are going to learn in this topic. First, introduction to distillation. Second, application and example in industry. Third, principles and mechanisms. Fourth, advantages and limitation. And the last one, isotropic distillation.
Distillation process is a process of separating various components of liquid solution by heating the liquid to form a vapors and then condense to form a liquid.
There are two physical concepts of distillation. First is no reflux and half reflux. This condense means the liquid mixture is totally condensed and no liquid is allowed to turn to the still, and it has low purities in the product. So the example of no reflux is flash and simple distillation. The example of half reflux is continuous distillation.
There are two types of distillation. First, continuous distillation, also known as rastrification distillation, used for mixture of about the same volatility. The condensed vapor and the residual liquid are more pure. Second, batch distillation, also known as a differential distillation. Only one vaporization stage is involved.
The vapor from the lower tray will rise up and form the bubbles, which the hole permits the bubble to go through it. The liquid from the upper tray will flow down to the tray below it. The liquid and the vapor will be mixed with each other at the upper tray and equilibrated. After the mixing of the vapor and the liquid and the vapor will leave the tray in equilibrium. At the end of the process, the vapor will reach with the component A, while the liquid will reach with the component B. Some of the distillate product will recycle back into the distillation column, as we want to increase the purities of the component A.
Batch distillation is also known as a differential distillation. Only one vaporization stage is involved. For the process of batch distillation, for the first step is a liquid mixture is boiling in a steam bracketed kettle, and the next, the vapor is withdrawn and condensed as fast as it formed, in order to prevent the liquid and vapor to reach the equilibrium. And next, the first portion of vapor is condensed and will consist higher volatile component A. As the process proceeds, the vapor is reached with component A.
There are some example and application in distillation. First, the distillation of crude fermentation brew into alcoholic spirits such as gin and vodka. Second, distillation of crude oil into useful products such as gasoline and heating oil. Third, it also can produce cosmetic and pharmaceutical, chemical and manufacturing. The example is aspiration. Aspiration technology can produce argon. This chemical is used in light bulb to protect the filament, and also it can provide the glow in fluorescent tube.
There is some advantage when using this distillation process compared to other process. The first advantage is it is an efficient method for water softening for smaller purpose. Simple distillation can be used to purify water for home use when there is no water bottle or clean tap water available. For the second advantage, the distillation process is using the cheap apparatus. This enables the manufacturers to save money on their production costs. When purer compounds is needed, the process can be repeated over and over again until the required standard is achieved. But there is also some disadvantage of this distillation process. Firstly, it comes with an operational hazard. Because the process distillation is using heat, the biggest hazard is explosion. This explosion can happen when the system is not equipped with the appropriate precaution. Secondly, it can contribute to environmental pollution. For example, when refining a crude oil, it can lead to the release of harmful chemical in the atmosphere. This can happen when the refineries is dumped into the water improperly. In an azeotropic distillation, firstly, the azeotrope is a mixture of a liquid which the liquid and vapor are exactly the same at a certain temperature. It is a special class of liquid mixture that boils at a constant temperature at a certain composition. When azeotrope exists, it cannot be separated by a simple distillation. An introduction of a new component called entrainer is added to the original mixture to form an azeotrope with one or more off-feed component. The azeotrope is then removed as either the distillate or the bottoms. The purpose of the introduction of entrainer is to break an azeotrope from being formed by the original feed mixture. The function of entrainer is to separate one component of a closely boiling point. The other function is to separate one component of an azeotrope.
The concentration in the vapor phase is the same as the concentration in the liquid phase. At this point, the mixture boils at constant temperature and does not change the composition. This is called as minimum boiling point. The most common examples: ethanol water, carbon disulfide acetone, benzene water.
Azeotropic distillation. Let's say binary mixture AB form an azeotrope mixture. Entrainer C is added to form a new azeotrope with the original components. The new azeotrope AC is separated from the other original component B. This new azeotrope is then separated into entrainer C and original component A. Hence, the separation of A and B can be achieved.